Okay, on this question we got a teacher walks, cycles or drives to school. We've got the probabilities. If she walks to school, the probability of being late is 0.35. If she cycles, we know the probability she'll be late. And if she drives, we know the probability she'll be late. Which technique do you think is the one to use to start off on this question? And if you can come up with which technique, can you give me a reason as to why you've chosen that one? So, which technique were you going to use here, do you think? I know what you mean, I think you've used the wrong words.
Oh, yeah.
A tree diagram, yeah. You've got one thing here happening after another. The first thing you've got is how she gets to school. So, how she gets to school, she can either walk, cycle, or drive. And we're told the probabilities for walking, 0.1, cycling, 0.3, driving, 0.6. That's stage 1, how she gets to school. Laura, what is stage 2?
Late or not late?
Yeah, late or not late. So from each of these, we'll have an L or an L prime. L with that little dash there to mean not. So late and not late. Late and not late. When you're doing tree diagrams, give yourself enough space to put all the numbers on, because as you get over to the right, you get more and more arms. So, probably being late, if she walks, is 0.35. If she cycles, 0.1. And if she drives, 0.55. How can I find all the missing probabilities on the L dash lines? How can I work those out?
They all need to add up to 1.
Yeah, these two need to add up to 1, they need to add up to 1. So this one here is 0.65, this one's 0.9, and this one's 0.45. So that's a tree diagram, sort of come from GCSE level. Tree diagrams are what you use if there's something happening and then there's a stage 2 process, something happening after it. So part A of the question is saying, find the probability she is late on any particular day. Can anybody tell us how we go about then doing that? Probability she's late on any day. Yeah.
Do you times all the latency?
So you're sort of on the right lines. Can you tell me which of the outcomes here? I've got 1, 2, 3, 4, 5, 6 outcomes here. Which outcomes will give me what I want? Yeah, so that one there, I'm going to, all the ones I've putting an A on the end are going to give me what I want for part A. Yeah, it's just being late. So being late by this route, walking and being late, remember from tree diagrams, to get here I've passed that number, 0.1, and that number, 0.35.
Don't you, to find out the late, don't you do 0.1 times the probability of being late?
Yeah, on that one, yeah, so it's a 0.1.
Isn't it?
Times the probability of being late,
yeah,
if you've done that. So yeah, times by the 0.35. So that's going to give me 0.035. This one down here, cycling and then being late, that's going to give me 0.03. And the one down here, 0.6 times 0.55. 0.33, thank you. So for part A, the answer, I want being late any way at all. It's that way of being late, or that way of being late, or that way of being late. And what do I do for or?
Plus.
Yeah, plus. I add them together for an or. So those values I add together. What's that, 0.065 at that point? And you should get 0.395. We're all happy with what we've done there. Part B is saying, given she is late on one day, find the probability she walked. Can we put that into notation first of all? Part B. Given she is late one day, Find the probability she walked. Going to go with Hayley.
Is it L dash given W?
Okay, in the question, it's given she is not late. So yeah, the L dash, yeah, L dash is there. The given she's not late bit, that means that's got to be the second bit. And what's the probability she walked? So you had all the right bits in there, it's not quite the right way around. Okay, what's the probability, given she's late one day, that's here, find the probability she walked.
Isn't that given that it's not late, if you've got the dash there?
So have I read that one wrong? Given she is late one day, sorry, yeah, that shouldn't be there, thank you. Okay. So Will, do you want to tell us what the next thing would be if we'd come across this? Like in the last question we came across the conditional ones, what do we do first?
Do you have to do the thingy over thingy one?
The thingy over thingy is exactly right, yeah?
Probability of walking and late.
Yep.
Over the probability of late.
That's right, okay. These two things with the intersection sign and what's after the line comes down here. Okay, walking and late. Do we have the probability anywhere of walking and late?
Yeah.
Yeah, it's this one up here. Okay, 0.035. Do we have the probability of being late? Well, that was what we worked out in part A, wasn't it? That's the probability of being late there. At 0.395. So if you do that division, you should get an answer of 0.0886. Is that what you've got down there?
Yeah.
Okay, we've ignored the bit there. It tells us to give it 3 decimal places. So to 3 decimal places, I'll get that back. 3 decimal places, 0.089. Okay, that's what it said there in the question. Part C, given that she is not late one day, find the probability she walked. Given she is not late one day, find the probability she walked. Leon, could you give me the notation bit for that one? So top of the screen, just. Given she's not late one day, find the probability she walked.
Probability bracket.
What's the given bit? Given what, Leon?
Not late.
Okay, and where does that given bit go? Before or after?
After.
Yes. So not late will be that. And what is the probability they're asking for then? Walked. Okay. That's the probability we want. Bruty, can you do this bit here for that, please?
Probability of walk and not late.
Yep.
And probability of
Yeah, not late. Okay. Right, the probability they walked and they were not late. Do we have that?
Yeah. So we've got to work out.
Yeah, we've got to work it out. Where is it on here?
Just under the first end.
Yeah, it's here, okay? Walked and not late is this end point here. So to get this probability, it's 0.1 times by 0.65, which is 0.065. And on the bottom, the probability of not being late. Have we got the probability of not being late anywhere?
Probability of being late.
Yeah, we know the probability of being late, so it's 1 minus that. And if you work that one out, you should get an answer of 0.107. Okay? Any questions, queries about that one before we move on? Okay.